Hi, this is part of a series of videos on vector space classification. In this video, we will be discussing linear classifiers in vector space. If you watched the previous videos in this series, you may remember that a Rokio classifier is a linear classifier, while k-nearest neighbor is a nonlinear classifier. But what does that actually mean? Just to keep the discussion simple, we will be restricting our definition to binary classifiers in this video. With that being said, you can define a linear classifier as a classifier that decides class membership by comparing a linear combination of features to a threshold. The separator between one class and another changes depending on whether we are dealing with a 2, 3, or n-dimensional space. In a two-dimensional space, the separator is a line. The separator is a plane in three-dimensional space and a hyperplane in many-dimensional space. Let's start with two-dimensional space. The line usually has this form. X1 and X2 represent the document, and W1 and W2, along with the B, represent the decision boundary. If W1 X1 plus W2 X2 is greater than B, then the document is assigned to some class C. While if W1 X1 plus W2 X2 is less than or equal to B, then the document is assigned to the complement of that class. We can generalize these definitions to apply to a 3 or more dimensional space. A plane in a three-dimensional space can be defined by W1 X1 plus W2 X2 plus W3 X3 equals B. A hyperplane in a higher dimensional space can be defined with this equation. The same concepts apply in all of those spaces. The location of a data object relative to the line, plane, or hyperplane determines its class. While linear classifiers are very simple to use, actually defining the lines, planes, or hyperplanes is a significant challenge. In particular, linear classifiers struggle with noise documents. These are documents that are a different class from the main class in their area. How much attention should be paid to noise documents? How do you determine which documents are noise? In some cases, it isn't even possible to perfectly separate the data with a hyperplane. If it is possible to perfectly separate the data with a hyperplane, then the data is called linearly separable. If the data is linearly separable, then there are an infinite number of hyperplanes that can separate the data. It is a large challenge to choose the correct hyperplane to use for your classifier. Some will behave well on new data, others will not. It's also important to remember that there are other types of linear classifiers, such as perceptron and support vector machines, which iterate over the dataset and often perform better than simpler options. Rokio, k-nearest neighbor, naive Bayes, they're considered simple classifiers. They generate the classifier directly from the training data. They don't iterate. However, some problems are not linearly separable, no matter what classifier we are using. If the data naturally forms complex shapes, nonlinear classifiers such as k-nearest neighbor are a much better option. A linear classifier would struggle with a distribution like this one. The clump of orange documents in the upper right-hand corner would create a problem for the classifier. Thank you for watching, and check out other videos in this series.